Thank you very much, Edgardo. So this brings us to the second session. So Hilde, please, could you come on stage with the presenters, please? So I'll introduce Hilde as she's coming up. So Hilde Orten works as a metadata specialist at Sikt, the Norwegian Agency for Shared Services in Education and Research. Hilde is the current chair of the DDI Alliance Scientific Board. So over to you, Hilde, please.
Thank you very much, and thank you very much to the organizers. In this session, we have 3 presentations, 2 long, like 20 minutes, including questions, and 1 shorter with 15 minutes, including questions. And I'll do it a little differently so that after the questions will come and be answered directly after the presentation. So we are all women here on this panel. That's very nice. And the first presentation is by Joanna Schroeder. Would you please go to... Joanna will talk about smart metadata in action, the social impact of data commons. And Joanna is a passionate about data democratization and community-driven research, finding her way to the University of Virginia's Biocomplexity Institute, first as a data science,
research specialist.
Okay, and for the public good young scholar, and more recently as a data science research specialist. She performs innovative, socially impactful analyses, including studying issues of women and girls in Virginia using a gender, race, place, equity lens, and investigation U.S. Army soldiers' performance and career processing using open source text data analysis and large language models. Joanna is currently pursuing her master's in library and information science from Drexel University full-time and will graduate in June. So over to you, Joanna.
Thank you so much. So today I'll present our humble implementation of smart metadata in action called the Social Impact Data Commons, developed by the University of Virginia's Biocomplexity Institute. So here's an outline of my presentation. I'll start by giving some background on the Data Commons project overall, and then talking more specifically about metadata, how we evaluate the metadata and standards for the data common, and going more in depth on the core metadata we've used for the project. And then I'll end with some concluding thoughts. Okay, so motivating the data commons, the motivation here is really to inform equitable growth. So the University of Virginia has partnered with the MasterCard Center for Inclusive Growth, which is the philanthropic arm of MasterCard. And we have a shared vision to use data to inform equitable growth throughout different localities. So we find that local communities have a lot of data and expertise, right? They have data on policies, strategies, events, and social behaviors, but often lack the analytical tools in-house to drive policy and strategic development. So that's where we try to come in to partner with local communities to figure out their data needs. And we have this tool called the Data Commons that we think efficiently presents those needs and disseminates data for local communities. So our approach to really all of our work and the Data Commons process in general is called the Community Learning Through Data-Driven Discovery Framework, CLD3 for short. And CLD3 goes beyond traditional organizing aspects of collective action programs and supports communities in building capacity for data-informed decision-making. So on the outer wheel here, we have what represents the continuous interaction and communication across stakeholders, which includes activities like engaging community stakeholders to identify those issues, partner with subject matter experts to operationalize the issues presented by the community, and other things like share those learnings to drive change. In the middle, we have the data-driven learning process, which includes activities like data discovery and to measure and evaluate the data. And the frontier between those two wheels is really the active collaboration between all partners in this process. And we also have the data science framework in the middle, but I won't be going into that today. So as I've mentioned a few times, this idea of working with local governments and grounding in those specific local issues, I'll tell you a little bit more about the 3 implementations of the data commons we have so far. So all of these are the data commons insofar as they do share a lot of the same data and geographic entities, but they're really customized to the specific user needs of the groups we're working with. So the first one is the Virginia Rural Health Data Commons, whose primary stakeholders are the Virginia Department of Health, specifically the Office of Rural Health and the Equity Office in the Virginia Department of Health. The second, which I'll be talking most about today, is the Social Impact Data Commons. And the stakeholders for that one are the county officials and the chief data officers across 13 counties in the National Capital Region, which surrounds the Washington, D.C. metropolitan area in the United States. And then finally, the Fairfax Women and Girls Data Commons is the smallest project, which really focuses on the issues of women and girls in Fairfax County, Virginia. So issues for each of these data commons were selected on the basis that the policymakers that we were working with could immediately benefit from the provision of new data and metrics. So basically, we went to the policymakers and we said, what are you making a decision on in the next 6 months that would be supported by data? And we got a lot of different answers. Some things that we simply could not really, is really hard to measure with data in such a short time frame, but other things that were really interesting, questions about food insecurity, affordable housing, emergency services provision in the counties. So we thought that these examples really served as powerful exemplars to showcase the impact and value of the data commons. And I'll talk a little bit more about those specific issues in a bit. So the components of the data commons, I've probably talked most about the data repositories so far, and that's the data part of the data commons, right? So those are the data sets that support local decision making. We find that one of the most important things that counties need is, no surprise, below county geographies. To really make those informed decisions, counties need to know the differences within the county and where different things are happening. So below county geographies is super important to county level decision makers. And then the final feature of the data repositories that I wanted to highlight is that all of the data and code to create those measures is open access and fully reproducible. These data repositories live on GitHub and they're public repositories. And so some examples of data repositories include broadband, which has a whole host of measures on broadband, such as internet speed, and access to broadband in those geographies. Food, as I mentioned, food insecurity. That repository has measures such as access to staple foods in different localities, the rate of food insecurity, which I'll talk about in the tools and methods, but that's a novel way to measure food insecurity that gets below the county level, which a lot of surveys don't. And then finally, financial well-being, which has a lot of financial and income metrics. The data commons, the other components of the data commons, outside of the data, maybe more of the commons elements, are first off tools and methods, which are new open source tools for building those dashboards and building those data sets and building the dashboard that the data is displayed on. And these include new methods for calculating new measures. So these are disseminated mostly as R packages to do, firstly, demographic redistribution. As I mentioned, to get those below county geographies is really important for our stakeholders. So, and often custom geographies, right? The high school pyramids in the county, the health districts, whatever geographies they actually need data in to make those decisions. It's really difficult sometimes to obtain official statistics in those geographies, right? So we have an R package to do demographic redistribution to calculate those new measures, and also this R package to calculate food insecurity based on the local cost of living in Fairfax County, Virginia specifically, is where that government required that. Finally, the applications component of the data commons includes open source applications and code for assessing and accessing data. And so that is mainly the dashboard, which is where all of the data is displayed, but we also have APIs so that people can efficiently access the data and use it in whatever application they need. So here's a screenshot of the data commons, and I have annotated here how some of our core metadata supports the creation and dissemination of those statistical products. So this is uninsured population coming from the US Census Bureau. And this is how we've displayed it with the short name, the long name, and then here is a dynamic statement about uninsured population in Fairfax County, which is right there. Maybe hard to orient yourself, but Virginia is kind of here. I guess we didn't put the state lines in the map, but that's sort of what the data commons looks like. So I am going to be talking about core metadata for the data commons and how we've evaluated core metadata. And our core metadata is a custom standard, which includes 17 elements that aim to describe data sets accurately and richly, and more so to support the creation of the dashboard, which I think is actually pretty interesting, coming from researchers working on this project, which hearing the earlier talks was really interesting about how we can support researchers to create metadata. None of us were an expert in metadata and describing things originally, so we had this custom standard, and we, derived some elements from largely accepted standards, but primarily we needed to stand up this dashboard and have our users, the county officials, and people working in the data offices of the county, be able to interact with the dashboard and really understand the data. That's how it's displayed there. So it's sort of interesting how that purpose really bubbles up, and that's really informs a lot of the way our core metadata is designed. But it's disseminated in a JSON file on GitHub, which is also really important to us because it's JSON is a file type that's machine readable and human readable, so it's really easy for the collaborators on the project to edit those files. The lift for learning how to edit JSON is really low. And some examples of the core metadata I have up here. So one is category, which is sort of topical. A lot of times it's the data repository that I mentioned, so like there would be a broadband category, but other times it's more determined by the stakeholder. So for example, the Office of Health Equity that I mentioned, they have the Health Opportunity Index, and they wanted all of those displayed together as a category, so we kind of manipulate that for them there. A long description, which is also pretty interesting, as we're kind of a third party. We really are in the business of co-locating a lot of different data sets and also producing some new ones. So when we have this long description, we often take the metadata from the original data sets. Sometimes they don't have great metadata, so we are in the interesting position of writing more complete metadata than was originally given to us, or sometimes we have to contextualize the measure specifically for a user who's working at that lower county level, right? So what kind of caveats might you say for interpreting a measure at a lower level? Aggregation method is an example that is derived from the DDI, and then also citations. That's so if a measure is based off of an equation that is cited in a paper, we of course want to credit that, and so that's derived from the BibTeX LaTeX standard. So I really wanted to talk about how we've evaluated core metadata for this project to make sure that we're doing a good job, right? So we evaluate our evolving metadata and standards, not just core metadata, but all of the metadata and standards against the FAIR guidelines. So we have done a self-evaluation, and then we've also used the RDA FAIR data maturity model to evaluate our core metadata. The other thing we've done is we've implemented this internal testing infrastructure, which really evaluates the entire data commons system, not just the metadata, and that uses a GitHub runner. And each day the runner clones or refreshes all of the linked data repositories and executes specified tests, which are Python scripts, on the data repositories. So for example, the check percent data test checks if all of our percent data is in the proper range to display on the dashboard and not cause confusion. And that doesn't have to do with metadata, right? That's just a system-wide check. But a test like the test measure info key checks whether, and measure info is our metadata file name, checks whether our metadata files have those valid keys or entries for each variable. So I'll just present a little bit about how we've evaluated our core metadata and what we found. So here is our evaluation according to the RDA FAIR data maturity model. As you can see, we're doing pretty well on findability and accessibility, but like the conference, our interoperability could use some work, which really does come down to the fact that we're a custom standard, right? So we have a little bit of ways to go in terms of translating our standard to widely used standards to make it more interoperable and then findable. And then one thing I just wanted to highlight about the FAIR data maturity model is that it sort of prioritizes those indicators, right? So we can know essentially an action plan. So we have one essential indicator that we have not considered yet, which would be our first priority, which is that metadata is guaranteed to remain available after data is no longer available. And since we use GitHub as our way to store data and metadata, obviously there's a built-in versioning that's happening there, but it's not clear if that is enough, right? If we should build into our system more persistent metadata. And to present a little bit about the results from our internal testing schema, I'll just go over what I think is most interesting here. So you can see these results are actually from a while ago, just because I think it's more interesting to talk about how this evolved. Basically, we have some poorly specified tests, which is really just finding out that we don't really have conceptual clarity among ourselves of what we should be testing about our metadata. So I'll just point out this one, this test measure info missing measures, which is designed to check whether our metadata is missing any measures. So if we have metadata missing. And we found that this test was running on our geography data. And then we thought to ourselves, do we need to hold geography data to the same standard that we hold all of our other data to? Why or why not? How are the concepts kind of murky there? So we were doing poorly on that test, and so we changed the test because it wasn't really a standard we wanted to check against. And I think I've run out of time, so you can just read as fast as you can our next steps. And I'll just thank my co-authors really quick. Thank you.
Yeah, and are there any questions for Joanna, please? Arafan? Can Arafan have the microphone, please?
Sorry to make you run so far. No. I'm curious about the methods you're using, and I asked this because of another project I'm on, but how are you getting sub-county level data? Are you using like small area estimates? What are the kinds of methods that you're using to do that? Because it's really hard to get that data, and I'm just curious because of the use case.
Yeah, so it really depends on the measure. So I mentioned broadband speeds. Since that is not really something that has to do with people, we get that from a service called Ookla Speed Test, which is when you go on your phone, hey, how fast is my internet speed? Ookla gathers all that data and then delivers it as like a social good product in 500 square meters. So that obviously is pretty easy to translate to a small area estimate for a county. Other estimates, for example, that might use US Census geographies, we have to have county level parcels and then do like a demographic redistribution right from a county level parcel, make some assumptions about how people are distributed within a county to kind of reform those. But it really is, I mean, it's dependent on the original source of the data and how we want to bring it down. Some are easier since they're actually bigger than like a census geography, for example. To create like a business district is often bigger than a census tract. But yeah, it really depends.
Okay, thank you very much, Joanna. And now, Ligia, please. Well, this is Ligia Nobrega. She will talk about metadata for gender statistics, a practical example from the European Institute for Gender Equality. Ligia is a gender statistics expert working at the European Institute for Gender Equality, EIGE, where she is currently responsible for the EIGE's gender statistics database. Since joining EIGE in 2010, she contributed as principal author to the first edition of the Gender Equality Index, released in 2013. Additionally, she has been supporting the development of EIGE in 13 indicators on intimate partner violence. Her responsibilities include leading gender statistical activities, advocating for gender-informed policymaking, and creating and executing methodologies for monitoring gender equality frameworks. Previously, she worked at Eurostat, developing capacity-building processes on gender statistics within the context of international statistical cooperation. Prior to Eurostat, she has been working at regional and national level in gender equality, advocate, and community-driven development. Ligia holds one master's degree in sociology and social analysis and another one in project management. Please, Ligia.
Well, thank you so much for the extensive presentation. I'm sorry for taking so much time for that. I want to start actually by acknowledging also a big team that has been committed in developing IGE's gender statistics database, which I'm pleased to come here today and to present. And you might have understood that I'm not going to talk about JSON or any other units of measurement, as you have been very much committed to do in the previous panel. But maybe I can already tell you that one of the main outcomes is probably, that I expect, is probably to convince you that gender perspective is also important to be considered when we are talking about not only statistics, but also about metadata itself. So, yeah, I will skip just this outline. So at the very first, I will start by talking what is the basic understanding of gender statistics, because it's important, it's one of the core elements of my presentation here. And it is not a discrete field of statistics per se, but rather something that cuts across the traditional fields that we are used to approach, to work with. It should reflect properly the differences and inequalities or equalities in the situation of women and men in all areas of their lives, and considering also all their diversities. The data are collected and presented disaggregated by sex, and this is quite important as a primary and overall classification system, should reflect gender issues, be based on a conceptual framework and definitions that capture all these aspects that I mentioned regarding women and men's lives. The data collection methods should also be quite attentive to what could be stereotypes, social, cultural norms that may result in gender biases. So why do we need a gender perspective? If you are not convinced yet, but so I said disaggregation of data by sex is important in gender statistics, still not exhaustive. The social relationship between women and men are very often more relevant rather than their simple biological differences. I will just give you an example. When we talk about crime statistics and about homicide, if we don't consider the relationship, or if we don't know the relationship between the victim and the perpetrator, we might end up by not understanding if it is a femicide afterwards. It's also an important instrument for monitoring and evaluation of all our projects, programs. It's a fundamental tool afterwards to be able to mainstream policies and make them more gender sensitive. So this element of mainstreaming gender into statistics, it's quite important that you might be understanding now. And I want to highlight this because this really needs to be considered since the very beginning of any statistical process. So through the data collection, statistical production, statistical analysis, the publication and dissemination, and through drawing the metadata as well. So women and men in all their diversity should be equally involved in the setting of the goals and considering throughout the process, as I said. This was a nice animation, but it ended up, but it's static now, but it's okay. I just want to jump immediately into what is our IGES Gender Statistics database. Actually, we published it for the first time in 2016. IGE received quite a prominent mandate when it came to statistics, and we ended up by needing to develop internally a statistical information system. At the very beginning, we didn't have our own statistical activities, so we actually started digging into other statistical data sources, and we put them all together into a one-stop source for gender statistics, making it a structured guide to assessing gender statistics and making it more easily for our diversity of stakeholders afterwards. Okay, so IGES Gender Statistics Database is actually a collection of statistical data and associated metadata pertaining specifically to gender statistics. At the highest level themes, we have 8 entry points currently. Initially, we just had 6. But it has been growing. The database logical structure is based on the STMX standard for the organization, production, and exchange of statistical information among users and providers of statistics. So we are very grateful for this guide because it was quite helpful when we started developing this tool. Then the database structure. So we have data sets, which is basic lowest level organizing elements or building blocks. And our approach towards data sets is the one recommended by Eurostat and within the STMX reference. We display it to users with help of dataset views, and you can see here they underline some data visualization, so heat maps, line charts, bar charts, vertical and horizontal, and also the functionality of customizable data tables. As I said, so we relied heavily at the very beginning of the database publication on external data sources. Currently, we have been progressively establishing our own statistical activities, aiming to address some serious gender statistics gaps. You would agree with me that gender-based violence, for example, was one and still is one of the more critical areas of gender statistics. So we already have our own surveys, and you can see here that data collected by us, it's already 18% populating the database. Here counts with our own surveys already and a long-standing statistical activity established by the European Commission, which is on women and men in decision-making positions. 2% are data or indicators developed and computed by IGE. And here also you might be familiar with the Gender Equality Index that we release every year. But maybe not so familiar, we also compute data on female genital mutilation. Okay. So, three main elements that we consider within the database, the development of the database, is, or principles, data is disaggregated by sex. I already mentioned that, and often also we try to include other additional characteristics, mainly to tackle very current, actual concept of intersectionality. Microdata, we also deal with microdata. It's anonymized and properly labeled, but basically we disseminate macro data. And all data are accompanied, and this is a very important principle for us, by appropriate metadata. So we try to have extensive metadata. It's a crucial and integral part of IGE's gender statistics database. Why we have metadata and why are we so meticulous? So we actually think when it comes to gender statistics, it's very important to be able to assess and on one hand, and to ensure the data quality, so, or which data we are picking to use and to do gender analysis. It has key methodological information on the sources of the indicators, the coverage, the frequency, the usual categories that we approach for comparability as well. Understanding and interpreting, and afterwards the data, and afterwards to do gender statistics analysis. So we basically have two types of metadata. One is structural metadata, and the other one is reference metadata. So the structural metadata considers structured description of the way the statistical data and the reference metadata are organized. This is embedded in the data, such as names and codes of data sets, dimensions, the code lists of criteria and attributes, and the end user does not necessarily need to be aware of most of the structural metadata, but we have an administrator guide which can be given to any user that desires so or requests it. So the reference metadata actually is provides additional descriptive information on the concepts that are used, the data collection and the methods behind employed, and as I said, assessing the quality of the data from a gender perspective as well. So it is extensive, mostly free form description of data. It includes, but it's not limited to, I have here several points, so what the data purports to measure, how the measurements were made, how the measurements should be interpreted, who is responsible for collecting and disseminating this data, how often the data are updated and disseminated, so the frequency, the regularity, where the updated data and additional information can be found, the quality of the data overall. Here it was also supposed to be a nice animation where you could have a snapshot of how the metadata is displayed in the database. So it shows the origin and other relevant data characteristics, analyzes the gender-specific issues, helps to interpret the data, and supports gender analysis. A bit kind of a summary or conclusion. So metadata enables users to apply gender statistics, our stakeholders overall. We have from researchers to policymakers, so to their work with more confidence, with accurate and effective manner. We also have journalists as stakeholders, for example, so mainly just to explain you that not everybody who uses our IGES gender statistics database is a prominent statistician or is very familiar with statistics, so we wanted to make it less scary in a way for these people. So integrating gender into statistical processes involves gender doing data collection in a gender sensitive way, developing gender sensitive indicators, having in mind or establishing gender sensitive methodologies, but also reporting comprehensive metadata, aiming as well to improve gender statistics. So metadata must explain the gender-specific quality considerations, and it's very good that I am at the end and I don't have to read through all these, but I put here several questions that must be taken into account when we want to highlight the gender-specific quality considerations. So please do, we must make sure that metadata provide adequate information on how gender issues have been addressed in the statistics. And just to finish, a famous quote already within our institute for quite long: what is measured becomes visible, what is visible can be explained, gets monitored, can be improved afterwards. So I think that we all have a big responsibility on that, mainly when developing better metadata. And I'm happy to talk. Yeah.
Thank you very much, Ligia. Thank you very much. And then questions for Ligia. Darren?
Oh, hi there. I mean, this is very much not a political
I know,
question, but I noticed you mentioned gender and sex throughout the presentation. Now, what do you think are some of the challenges for statistical classifications and taxonomies that have emerged in the last few years because of the trans movement?
I was expecting this question, actually. I got it everywhere. Maybe two things, maybe to be quite quick. We, at the beginning of developing the database, we developed also a technical document explaining exactly what are the quality considerations that we have. This document was published in 2021. The discussion, as you mentioned, has been more and more prominent when it comes to statistics, and of course that IGA is expected to provide some guidance on that. We are at the last stages of publishing an update of this technical document, which will provide at least some clarity. How do we approach I don't want to say interchangeable because it's not, and so basically we focus a lot on intersectionalities on one hand, and also we try to map a bit the different approach. They are not exactly different approaches, but the practices, mainly within the European Union, within national statistical offices, when it comes to recording sex disaggregated data or collecting, and also considering other genders, if you want to. But I'm a bit careful with the concepts because I think that is important. I'm not going into this political, but I mean, we want to solve the problem, at least in my area. We want to at least to provide some reference, some guidance, and to help to when it comes to data collection and to gender statistics afterwards. So, thank you for your question.
Okay, thank you very much, Ligia. And now our final presentation will be performed by Julie Lenoir et Julie Baron. Soyez les bienvenus. And they are going to talk about implementing standards for data catalogs in research organizations, a case study of the French Institute of Demographic Study. So first, Julie Lenoir. She graduated in 2018 from Sciences Po School of Research, where she obtained her master's degree in economics. She joined INED in August 2020 as an IT engineer and works both on questionnaires and survey monitoring tools and on data and metadata dissemination processes. And Julie Baron, she has been working as an engineer in documentation and data dissemination of surveys for 4 years at INED. Her role is dedicated to providing reliable and accurate data for research purposes and increasing the visibility of the data produced. She holds a master's degree in sociology studies of the University of Paris-Sorbonne.
Thank you, Hilde.
Yeah, the floor is yours.
Thank you. So we want to present to you the work that we have been undergoing for now 4 years as a dissemination team, and more specifically what it meant for us to meet standards and the consequences it had on our workflows. So we'll start with a brief introduction to present to you INED, which is a small research institute, and then we'll explain how we implemented our new catalog and how it impacted our dissemination process.
So to briefly introduce INED, we are a research institute in demography that conducts, among other things, quantitative surveys and designs demographic and contextual databases. We are around 250 staff members with research units and research support services. At INED, we have 8 main research teams ranging from family to migration, health, and environment. And INED was officially established in 1945 and has been conducting surveys since 1942. So this means we we have a vast wealth of data and surveys that need to be further valorized. We used to disseminate some of the data through Ketley Projet d'eau diffusion and documents these data using the Nestar software, but without a structured policy and with few constraints. And many things changed starting in 2018. The GDPR came into effect, as well as the first National Plan for Open Science, which stipulates that research funded by public funds must be made available according to FAIR principle. Following this, INED wished to set a 3 years embargo between the end of the data collection and the dissemination of its survey, and adopt an open science charter in 2022. Therefore, it was in this context, and because our Nestar software was no longer being maintained, that we wished to establish a real policy for disseminating our surveys. This involved changing our catalog, switching to new documentation software, conforming to FAIR principles and European standards, and ultimately changing our way of working to disseminate on a just-in-time basis.
So let's focus now on how we implemented Data INED, which is the INED's data catalog. So I'm going to look at 3 steps: metadata, standardization and enrichment, how we chose the software, and how was the migration process. So the 2 standards we started from were FAIR and DDI. So we stuck with DDI codebook, but we needed an upgrade clearly. And as a National Research Institute, we are kind of bound to subscribe to the FAIR standards. So we knew we had also some work to do in that area. So we worked on our metadata, and this was a twofold process. So firstly, we chose to harmonize our metadata following the Consortium of European Social Science Data Archives, CESDA, standards, which mostly meant adopting new control vocabularies. So you have here a list of fields that we worked on the table, and so this meant going through current content for each survey and each field. So this looks like actually this, and synthesize the whole text we had in the description we had of the processes of the data collection mostly, and to fit that in control vocabularies. Moreover, we did not just standardize, we also enriched our metadata because we wanted to make sure that important information was available for each and every survey in our catalog. So, for example, data collection dates and periods, abstracts, dissemination dates, access conditions to the data, such things. We also started to search and reference bibliographic resources related to the surveys, with many researchers' publications that explain how the surveys was made and how they can be used. And we added links to these resources in all relevant references. So at the same time, of course, we worked on the new software. So we hesitated between 2 softwares, actually, Dataverse, that most people know because it's widely used in social sciences, and NADA, which is maybe more niche in that regard. And we obviously landed on the second one because it fits our need best. So you have here like a small table of the criteria that we use, but I want to focus on 2 things. Firstly, the fact that NADA was very easy for us to install and maintain on our servers, and that was a very important point. And secondly, that we really liked the way that NADA displayed metadata. It was really exhaustive, and for us it was really important, and we also thought it was more user-friendly, actually. So we have new metadata, and we revamped metadata, and we have a new software. So now we migrate. So it took like 1.5 years for us to be able to come to this point and to engage into the migration process. I'm not going to bore you with the details of everything, but I want to focus on 2 points. The first one is that this requires many back and forth, and it has to be thought out in advance before engaging into it. For basic example, you need a URL to create a DOI, but to create a URL, you have to initialize the references into the catalog, and so you have your DOIs, and then you have to take those DOIs and put it back into the metadata and back in the catalog. So, this is something that you need to consider. So I want also to point out that we used basic technologies to do this, right? So it was like XML files, XLS transformations, R packages, APIs, RDA files. We really stuck to the basic here. So you can read more on the process if you want.
So now that we had a new metadata catalog with more detailed and demanding documentation, We also needed to change our way of working. To explain this to you, there is this diagram that includes most of the steps an INED survey goes through, from conception to dissemination. And previously, I would receive the survey data and the documentation at the end without being involved in any previous steps. I would essentially discover the data and documentation once the researchers had finished exploiting them. The issue with this way of functioning is that the dissemination of data was not included, for example, in the administrative documents or agreement, like who should disseminate, who is the contact person if there is any question, for example. And we were also losing a lot of information over time, such as the exact dates of collection, for example. And for the example in the slide, there were data constructed by several people, each with their own documentation, not necessarily provided with the data. And I couldn't understand the way the variable was constructed. So the lessons we learned is that the dissemination of data must be considered from the design of the survey and throughout the whole data life cycle. So now these are the steps, the stages at which I intervene, either to retrieve information or document in real time, or to provide information to anticipate dissemination. And how do we do in practice? Our new documentation medium is a Word form, like docx, that has all the DDI fields we use and control vocabularies inside. This Word form allows us to exchange with the team at each steps. We also retrieve anything that can be useful to us as we go along, and we have guides who provide good practices for improving both data and metadata quality. For example, at the end of the data collection, we retrieve the input masks from the data collection software. For the metadata, statistician responsible for the response rate put into the form. And and finally, approximately 50 fields are thus completed through collaborative and continuous filling that we supervised. With the guidelines we provide for data construction and by regularly meeting with the teams, the data is better constructed, variables recoding are more documented, and we receive higher quality data.
So in practice, we relied on the same technologies that we use for the migration. So from the data, any kind of data file, usually it's a SAS file, and the metadata form in Word, we extract information from these two sources with R to produce the DDI XML that is compliant with CESDA standards. And then we have now a quality control step that relies both on the CESDA metadata validator, which does exactly what it says it does, and an internal process, which is a process prepared by Julie and me. And so when everything is checked for, we publish the metadata into 2 locations and then 3, so data INED, quels les projets de diffusion, which catalog is harvested by the CESDA data catalog. So, it goes in 3. Our metadata you can find in 3 different places. So we hope we were able to convey how our practices have evolved throughout the last 4 years, and there is always still some work to do. Specifically, we want to add new types of data to the catalog because INED does not only do quantitative data but also qualitative data. And we will also wish to make the catalog accessible to English-speaking users, which should come in the next year or so. Thank you.
Thank you very much, Julie and Julie. And are there any questions? Yes. Barbara?
You were talking about controlled vocabularies. Do you mean fair controlled vocabularies? And when you talk about metadata, do you mean fair metadata?
Yes, yes, we do. So we use mostly CESDA control vocabularies, and there are discussions in the CESDA community of how fair those vocabularies are, and there is some, ways to improve them to make them fairer. But yes, we are talking about fair metadata.
Yeah, other questions? Ashana?
You mentioned that you actually kind of got citations for your survey data and referenced them. did you do it manually or did you do it automated? And how difficult was that process?
Yeah, so we did it manually. For context, we had 250 surveys to go through. And INED is also a publisher. So most of the references we kind of knew because it's from the population, which is the INED's work. So we read actually lots of old articles on surveys, and this was quite nice actually to learn more about the history of INED that has been producing surveys for quite a while.
Any more questions? Well, I have one question. Since I come from one of the organizations that was behind the NASDA, so I would like to ask you, what are the most beneficial with moving to NADA, in your opinion?
So I would say that in terms of the admin interface, it's very easy to use. So I mean, we are basically the dissemination team with Lucas that is here. So, we need to have tools that are easily usable. So we really like that. And you can just upload like the DI, an XML file, a DCI 2.5 into NADA, and it does the work for you. So that was also really nice. We have a great communication with the development team. And, I have been working with them to improve NADA and to add new specific things that are useful to us and might not be useful to everyone. So, all in all, like in hindsight, it was really the best choice for INED to go to NADA.
Okay, so thank you very much, and thanks to the audience for listening, and yeah. That is the stylish